All right, in this lesson, we'll talk a little bit about increasing and decreasing functions and how you use it when you've been asked these questions on an A-level paper. So we would have seen this from O-levels where we have a line, and if we needed to find the gradient of that line, we would, in many cases, we would either choose 2 points, and then we would use the formula. We would use this formula y2 minus y1 over x2 minus x1 to find a gradient, which we called m for a line y is equal to mx plus c. But what I want you to notice is a couple of things here I'm going to mention before I get going. Is that when you find a gradient, you're finding a difference in y over a difference in x. Or in other words, some people use rise over run. So some people, if they're very skilled with the triangle drawing, it's a rise over a run. But in any case, what you're actually doing is finding the difference in y, and you're dividing that by the difference in x. The other thing to mention is if the line is going up like this is called an increasing function. The gradient is increasing. Actually, no, the gradient is the same, but the function is increasing. So for example, when x is this value, it's a higher answer. When it's 0, it's even higher. When it's this number here, it's even higher. So this function is increasing. So this gradient will have a positive value. So this will have a positive gradient there. If, however, according to this blue line, it's doing that, this is a decreasing function, so this will have a negative gradient. Okay, so because as you can see, as you are going down, the gradient, the function is getting less and less. So for example, here we started on a high value, but then if we come down a little bit lower, it's even lower, lower there, and so on. So that's a decreasing function. Now bear that in mind as I go through the next part of this video. So I'm going to start off with a new function now. So I'm just going to get my graph drawn, and we're going to have, I'm going to draw a quick quadratic function and use the same sort of idea to explain the concept. So here I have a quadratic function. I'm going to call these points where it cuts the x-axis. I will call those points there A and C. So this point will be A, that point will be C, and right where the function, right where we have the symmetry of the function, symmetrical line of the function, I'll call that B. So I'm just going to call this B here, and I'm going to draw a broken line to say that's the symmetry of the function. Okay, all right, or that's going to be the x value for which the function has a minimum value. Now, lots of jargon I'm using there when I'm talking about this, but if you're watching this video, you're probably looking for an A-level question to be done, and you understand most of this jargon, so I'm not going to go into too much detail about it. But when I said minimum value, I mean the bottom of the function here, or this is also called the turning point of the function. So I might just literally stick an arrow there and say turning point. All right, now let's get back to what we're doing. We're doing increasing and decreasing function. The question on an exam paper will ask you for the range of values of x for which the function might be increasing or decreasing. What I want to put to you is this. If you look at this function coming down here, you will realize that for every part of this curve going down here, the gradient is negative. I hope you realize that. Every part of it is negative. So if I decided to sketch a quick gradient there, that gradient is a negative gradient. If I sketch a quick gradient there, it's still a tangent there, sorry, it's still a negative gradient. Long story short, as you can see here, for every value of x that you have, this function is decreasing. So if I go there, I get a value here. I probably should draw that in just so you can see. if I choose a next value here, it gives me whatever that answer is there. But if I choose one a little bit lower, it gives me another one there. So as you notice, the further down I go, the less these values here become. So this function is decreasing up until it gets to the turning point. When it gets to the turning point, the rest of the function is now increasing, going up there. So you can see that from here, if I choose, let's go for a different color. If I choose to go there, okay, so this x value there, it gives me that answer. But if I come along here, it gives me that answer, which is higher. If I go up here, it gives me an even higher answer there. So the function is increasing there. So long story short, if I want the range of values of x for the function increasing, let's just say we go with increasing, it will be x greater than b. Sorry, let me write my b. So x greater than b, because from this point here where b is, the function is now increasing, and for all values of x beyond that point, this function will carry on increasing. So let's go on to now a more challenging question and see where this all comes into play. All right, so here we have an exam type question, and I've taken the liberty of drawing the graph of this function while I was at it. So it says, for what values of x is this function here an increasing function? You could be asked for a decreasing function, and I'll talk about that in a bit. But let's scrutinize it from the graph first. Okay, so if you look all the way up here, for this whole length of values here, this function is increasing up until it gets to -3. So it's going to touch here, because this is a turning point here. So this is -3 at this point. So you can see the function is increasing up until you get to that point. You hit the turning point, then the function is decreasing. If you follow my my laser pointer, you will see that I have to go down. The function is decreasing. And then you hit this point here, which is 1, and then the function is increasing again. So if I make this value here 1, then you'll find that the function will start increasing once we hit this turning point. How do we, now in the exam, you probably wouldn't have this graph. I just used the graph as a demonstration to show you what's actually been happening. Now I'm going to solve it mathematically as you would when you're solving this question for your examiner. So the first thing you're going to do, so if I have a function f of x is equal to x cubed plus 3x squared minus 9x minus 27, the first thing I will want to do is find the derivative, the first derivative of that function, because as you might already know, when you differentiate the function, you're actually finding the gradient at any point on that function. That's what you're actually doing. So let's differentiate it. This becomes 3x squared plus 6x minus 9. And just like that, what we have is a quadratic. Now, if the function is increasing, then we've mentioned before, what will happen is the gradient will have to be going up. It has to be greater than 0. As you remember, we mentioned on the slide before. So it has to be going up. The function will be increasing as you go up. If it's a decreasing function, then what will happen is that your inverse of x will be less than 0, because it means you'll be going down, getting negative. And if it's equal to 0, then that is a turning point. So anyway, so we're only interested in if it's increasing. So what I'm going to now do is say that this means that 3x squared plus 6x minus 9 has to be greater than 0 for the function to be increasing. All right, so let's go. Let's go work that out. I would simplify my function by dividing by 3 because I've got a load of multiples of 3 there, just to make life easier. So I'll now have x squared plus 2x minus 3 is greater than 0. So all I've basically done is divide that by 3, that by 3, and that by 3. And now I can quickly factorize that to then give me x there, x there. To make that 2, I will need 3 and minus 1 to make 2. And then if I multiply them, I get 3. Again, I'm not going to explain how I've done that because, like I said, if you're doing this as an A-level student, you should know how to factorize a quadratic. Anyway, what I tend to show students at this point is something like this. So I'm just going to quickly sketch my curve. This is a quadratic with a minimum value, and this minimum value means that the curve will look like that, and it cuts the x-axis in 2 places. We can see here it cuts it at positive 1 and minus 3. Again, you should know how to deal with that. So 1 and minus 3. For the function to be greater than 0, it means that we want what's above the x-axis. So basically the region that we want is out here and out here. So therefore the solution here, this function will be an increasing function when x is less than minus 3, as you can see there, because if we go further this way, we're getting less and greater than 1. So an x is greater than 1. And that's where we'll find that the function is an increasing function. Now, let's go back to my graph that I had earlier here. And from here, did we not mention already that if the function is 3 and below, it's an increasing function? Because look, the function is increasing for all values that come after minus 3. So all these values here. And then when we got to 1 here, it was all the values that came after 1, greater than 1. And that's exactly what we got as our answer down here. So we can see that for any value of x less than minus 3, the function is increasing. Any value of x greater than 1, the function is also increasing. Okay, and that's basically the general idea behind it. So now what I'm going to do is on the next slide, I will give you one to do. I'll pause the video for a little while and give you a chance to have a go at it. And you pause the video because I'll only pause for about 5 seconds. And you have a go and then see if you got the same answer I've got. All right, so I didn't write down the instructions of the question, so I'm just going to tell you what it is. Find the values of x, or the range of values of x for which this function is increasing and decreasing. So we want both of them, increasing and decreasing. So pause the video and have a go at it. Then I will work it out and see if you can get the same answer. So I'll just wait a few seconds. Okay, so provided that you've paused the video and you've worked it out, let's see what we've got. So first of all, as you know, if it's an increasing function, then your dy dx will be greater than 0. If it's a decreasing function, then your dy dx will be less than 0. Okay, so you've got quite a few things to work out there, but we'll work it out real quick. So first of all, obviously, based on this only, you have to find dy dx. You don't have a choice. So dy dx, actually you do have a choice. You can plot it on a graph and then check it out there. Anyway, dy dx will be minus 3x squared plus 4x. And then what I'm going to do now is, I know that this is a quadratic and it's going to produce a couple of answers for me, but let's go. I've got, this implies that minus 3x squared plus 4x is greater than 0 for the increasing function. Probably write this here. Increasing function. And then I will just go ahead and solve this so I can factorize out the x. Yep, so thereby giving us, once we take the x out, that will give us minus 3x plus 4. I'll treat this as an equal to 0 for now, because once we draw it, we want to make sure that we are doing this rather correctly. I like drawing it because you can see why certain things happen. So anyway, this implies that x will be 0 and x will be 4/3 once you sort that out. Now I'm going to quickly draw this on a graph. Like I said, I love my graphs because I can see what's going on in the world with that. And for this graph then, it will be a graph with a maximum value going through the origin. How do I know it's maximum, you might ask the question? Well, the coefficient of x squared is negative, so that tells me the graph is going to have a maximum value. It cuts the x-axis at 0 and 1.5 there, or 4/3. So I should probably just put that in to get rid of any confusion. That's 4/3. Now, you remember that when we started solving this, it was greater than 0. Greater than 0 is above the x-axis. So the region that we need to concentrate our efforts on is in here, which basically means that we're looking for values greater than 0 and less than 4/3. And I can now say for an increasing function, the range of values of x need to be between 0 and 4/3. Okay, that's for the increasing function. For a decreasing function now, for a decreasing function, obviously the decreasing part of the curve is on the outside here, because decreasing function means below the x-axis. So it's outside here and outside here, which means that you're looking for values greater than 4/3 and less than 0. So for a decreasing function, the range of values of x we're looking for now must be greater than 4/3 and less than 0. Okay, so did you get those answers? I hope you did. And that's the end of this video. So I hope that this was helpful. If there are any things you thought I missed out or you'd like me to, have a look at for you, then just drop me a comment down below and I'll be happy to look at that for you and send you out a new video. All right, enjoy. Bye.